Okay, so welcome back. So we've already done this particular activity down to question 4, where we've identified the descriptive statistics and identified whether it's normally distributed or not. So now using the same spreadsheet, we're going to develop a frequency table to determine the probability of a student achieving greater than 70% in each of the assessments and indeed over the total performance as well. We'll also look at attendance as well, so we'll develop a frequency table for all 4 of the columns of data. So if you go into your Data Analysis ToolPak, what you'll see is this histogram function. I'm just going to click on OK just to highlight a few things. So in terms of the histogram function, one of the things that we will be looking at is obviously selecting data sets. So the selection of the data set has to be just a single column of data. If you select all columns of data, then it will apply the histogram to everything within those 4 columns. So make sure you just select the column that you're interested in. Equally, you also have this bin range. And a bin range, basically put, is where you are sort of kind of segmenting your data, if you like. So you want to know how many students have achieved 0 to 10%, 10 to 20%, 20 to 30%, etc. So you have to develop a separate table for using this histogram function, which is defined by this bin range. So we'll just do that first before we actually do the histogram function. So the first thing to do is just remind yourself what ranges you're looking at, and you can adjust these ranges as you see fit. So 0 to 10, 10 to 20. We're just putting an exclamation mark in front of the 10 to prevent it from moving straight into a date format. So if I just do it here, so 10 to 20, it automatically converts it to October 2020. We don't want that. So exclamation point just forces it into a text type format. 20 to 30, 30 to 40, 40 to 50, 50 to 60. Oops. Okay, and this is just for our own benefit. It's not actually used in the function at all in the histogram function. It's the bin range that we use in the histogram function. So we have 10, 20, 30. Hang on, because I automatically changed it. So I need to just change that to a general number. Okay, and the other thing that you can do is if you highlight a sequence of numbers which are going up in the same or increasing by the same amount, if you drag the little square box down, it should then just carry on that sequence. So what we now have is a bin range which is from 10 to 20. So the actual number in the bin range that we're looking for or looking at is actually the maximum number. So we're looking at anything that's below 10 within the first data set, anything that's between 10 and 20 and below 20 in the second data set. So we're now ready to look at the data analysis. So if we use the data analysis function, we can use histogram, and we're going to do attendance first. And we're going to select our bin range, which is this range here. So this is just for our benefit, but the actual bin range is just a single numerical value. And you can have it in degrees of 5, degrees of 2 if you wanted, but it's sort of kind of your own choice, right? And then I'm just going to pick an output range, and I'm just going to put it probably underneath the bin range. And then we also want to generate a chart. Okay, so this will generate a histogram plot of the data set. Okay, so if we click OK, think about it for a bit, mainly because my computer's slow. I'm just going to drag it down a little bit, make it a little bit bigger. Okay, so this is our frequency plot for, in this instance, attendance. Okay, so I'm just going to change the name to attend. This is just so that I can recall what each of the frequencies are related to, how it's related back to the data set. So I'm just quickly going to just do exactly the same for all the other data sets. So we only need to change now this, and obviously where we're putting the data. So I'm going to change the output range to here. And we also want a chart as well. Okay, so that you can see that the data is different. So this is now related to case study. And again, I'm just going to reformat the graphical output a little bit and bring it down underneath the table. So again, we just need to continue and choose another data set and another output range. I'm going to leave a gap in here and just go enter. Okay. And I'm going to call this now, this should be CBA. Yeah. And so on and so forth. So final one is histogram and data range total. Output range is that one. And chart output. And we've got our chart output down here. Okay, so we now have our total frequency for each of the columns of data that we're using. So then how do we generate a frequency distribution? So we've already generated a histogram, a visual representation of the frequency distribution with different grades at different levels of, there's a granularity of 10 marks in each, which seems fairly sensible. What we do need to do if we want to start asking questions about what is the likelihood, what is the percentage likelihood, or what is the percentage of students that are most likely to get 70 or above in attendance, case study, CBA and total. So we need to generate relative frequency tables. So relative frequency is basically a ratio really of your data set, and it takes into account the total number of samples or some data points within the data set. So one of the first things we need to do is just add up the frequency distribution. So we just type in sum and then select within parentheses, and you'll note that we've got 51, and if I scroll over here we've got 51 subjects, so that's useful. So it's working. So I'm just going to copy and paste across, so we have 51 across the board. Now in order to determine your relative frequency, we simply do a simple calculation where we take your actual frequency and divide it by the total number of subjects within your study. So the relative frequency of an individual student attending less than 10% is 0.1, so essentially 1% or so of the cohort. So one thing that we do need to do, because we want to be able to just drag it down to be able to do the analysis really quickly rather than having to copy and paste all the time, we need to actually fix the point of this particular cell. So the best way to do that is to use a $ in front of the number, and the number relates to this 48 row. Yeah. So when we actually click on the numbers within the actual parentheses, what you have is this is the frequency number, so we want that to change as we drag it down, but we want this to be fixed because that's the total number of individuals or total number of data points. Okay, so I'm now just going to drag that down, and hopefully what you'll see that actually you get a figure for it. Ignore this kind of 0 here for more. Part of the histogram function will also ask the question, are there any data points outside of your bin range? Yeah, but don't worry about that. You don't need to worry about that too much. So the next thing we can do is we can copy and paste that across. And what you'll notice is that actually it's automatically moved the cell reference point to the next population, so here and here. So again, if you just drag your square, move it down, and you can just copy and paste, and indeed paste again. So we now have relative frequency. So the next question we were asking was, what is the probability of a student getting greater than 70%, 70% in a particular activity? So in attendance, in case study, in CBA, in total, as a total overall total for your course grade. So it's fairly straightforward. Basically, all you're doing is you're looking at again a simple sum function where you take all the data relative frequencies from 70 plus, and you simply add them together. And so for attendance, approximately 47% of students will attend more than 70% of the class. The attendance thing is a little bit of a misnomer in some regards, because if you attend one class, that has a percentage value of about 8%, so that goes up in scales of 8. So this person who has an attendance of 10% is probably actually they have attendance of 8%, and it's basically they've attended one single individual class. I know, rubbish, isn't it? Okay, and then you can copy and paste across, and then that gives you the relative frequencies or probabilities of a student getting 70% or plus in the case study, so quite high in this instance. Yeah, CBA a little bit lower as you'd expect, and indeed for the course overall. So approximately 52% of students were or achieved 70 or above in this particular individual example, which is actually really quite good. Okay, so we now have ticked off the relative frequencies and generation of histograms and using the data analysis function, and particularly the histogram function. One of the things that you'll see is obviously there's lots of other potential opportunities to develop your data further in terms of regression analysis here, correlation analysis, covariance, etc. Generally speaking, Excel is okay at doing some of the stats, but SPSS is actually a lot better and gives you a more robust sort of application of data and a lot more options. So we will be moving on to SPSS in the next workshop session. Okay, so I'm going to stop there. Hopefully you've managed to be able to keep up with me and be able to generate these frequency tables, and indeed obviously generate the relative frequencies.